Dear students, now we are going to solve important problems in differential equations using Laplace transform. Before going to solve problems in differential equations, let's discuss some important formulas to be used in the solution of differential equations using Laplace transform. So this is the sample differential equation of the linear time invariant continuous time system. So for this given system, we are going to find out the general solution as y of t. Okay. So next, transfer function of the system. The transfer function is denoted as h of s. It is defined as the ratio of the Laplace transform of the output signal to the Laplace transform of the input signal. Here y of s represents the Laplace transform of the output signal. X of s means what? Laplace transform of the input signal. So transfer function is also called as system function. It relates the output with respect to input signal. So the next one is impulse response. Here impulse response means the response of the system if the input signal is the impulse signal. That means whenever we are giving the input signal as impulse signal, then the output is called as impulse response, because impulse signal, that is del of t here. The Laplace transform of del of t is what? 1. So at that time the output depends only on this system function. So here output is known as impulse response. So next, the important Laplace transform formulas are here. If the input is del of t, the Laplace transform value is 1. The Laplace transform of u of t is equal to 1 by s. Laplace transform of t into u of t is equal to 1 by s squared. Likewise, for this t power n, its Laplace transform value is n factorial divided by s power n plus 1. For example, here it is t squared. Okay, if it is t squared means here the answer is what? 2 factorial divided by s power 3. Okay, so likewise e power minus at into u of t. Here you can consider u of t is common for all the terms. Okay, so e power minus at u of t means its Laplace transform is 1 divided by s plus e. Here minus means here it is plus. Suppose e power plus at u of t. So for this formula, the Laplace transform is 1 divided by s minus a. So here if it is plus means we can put minus in the denominator. If it is minus, we can put plus in the denominator. Then t into e power minus at. So for this, the Laplace transform is 1 divided by s plus a the whole square. So in case of e power minus at means it is simply 1 divided by s plus a. If it is t into e power minus at means 1 divided by s plus a the whole square. Likewise, sin omega t. The Laplace transform of sin omega t is equal to omega naught divided by s squared plus omega naught squared. For this cos omega naught t, its value is s divided by s squared plus omega naught squared. Likewise, e power minus at sin omega naught t can be converted into its transform like this, omega naught divided by s plus a the whole square, because the sin omega naught t is multiplied with e power minus at. So we have to write in the denominator like this. So s plus a the whole square plus omega naught square. So likewise, e power minus at cos omega naught t means s plus a divided by s plus a the whole square plus omega naught square. So you have to remember all this transformed values, because in this solution of differential equation, in the last step, we are going to convert the Laplace transform into its original signal in time domain. For example, in the similar way we can say, what is the value of inverse Laplace transform of this 1 by s? So inverse Laplace transform of this 1 by s is nothing but u of t. Likewise, you can say 1 by s squared. Inverse Laplace transform of 1 by s squared is nothing but t into u of t. Okay, suppose here, what is the inverse Laplace transform of 1 divided by s plus a? It is e power minus at. Okay, so you have to remember this formulas. Okay, so either if it is this side means Laplace transform of sin omega naught t is like this. inverse Laplace transform of this is equal to sin omega naught t. Okay. So next one is differentiation property of Laplace transform. We have already discussed about this property in the properties of Laplace transform video. You can refer that video also. Here the Laplace transform of x of t is equal to x of s. Likewise, the Laplace transform of differentiation of x of t can be written as s into x of s minus x of 0. So here this x of 0 represents the initial condition of the input signal at time t is equal to 0 in time domain. That's why we mention as small x. Okay. So next one is Laplace transform of d squared by dt squared of x of t. Okay. So if we are having second order differentiation means we can get the transformed value as s squared x of s minus s. Here degree 2 means first we start with that s squared. Okay, then we can have s, that is 2 minus 1, and then we can have s power 0. So we have to reduce the degree like this. So s squared x of s minus s into x of 0 minus d by dt of x of 0. So likewise we can have Laplace transform of d cube by dt cube of x of t is equal to s cube. Here degree is 3. So s cube x of s minus s squared x of 0 minus s dx of 0 by dt minus d squared x of 0 by dt squared. So likewise we can go with any number. Okay. So next with zero initial conditions. So this is what the without zero initial conditions of this differentiation property. Suppose the initial conditions are 0. Initial conditions are 0 means what? All the x of 0 value becomes 0. Correct. So here x of 0 is equal to 0 means simply this term becomes 0. Okay. So we can write with the 0 initial condition Laplace transform of dx of d by dt is equal to s into x of s. Simply Laplace transform of d squared y of t by dt squared is equal to s squared x of s. Likewise d cube by dt cube, that is degree is 3 means s cube into x of s. So likewise you can say any order. So Laplace transform of d power n y of t divided by dt power n, then you can have the answer is s power n into x of s in case of zero initial conditions. So the first problem is to determine the impulse response with zero initial conditions for the given differential equation. So what is the equation given here? D squared y of t by dt squared plus 3 dy of t by dt plus 2y of t is equal to x of t. So here the given condition is what? Zero initial condition. So there is no y of 0 value and x of 0 value. Both becomes 0 here. Okay. So that is the given condition here with 0 initial conditions. So in the solution part, first we have to take the Laplace transform on both sides of the given equation. So here Laplace transform of d squared y of t by dt squared plus 3 is a constant. We can take it outside. So 3 into Laplace transform of dy of t by dt plus 2 into Laplace transform of y of t, that is equal to Laplace transform of x of t. Okay, then we can substitute the value of the Laplace transform of differentiated signal. So here d squared, Laplace transform of d squared of y of t means what? It is s squared y of s. With the zero initial conditions, you have to remember that. Okay. So s squared y of s plus 3 dy of t by dt means s into y of s plus 2 into Laplace transform of y of t is nothing but 2 into y of s, that is equal to x of s. So all these terms y of s is a common one. So we can take it outside. Y of s of the remaining terms are s squared plus 3s plus 2, that is equal to x of s. So what is mean by impulse response? Impulse response means the input signal is a impulse signal. Correct. So input signal is a impulse signal means here x of t is equal to del of t. Then x of s becomes 1. So we can say x of s becomes 1. Is that okay? As we know that the transfer function of the system is given as h of s is equal to y of s by x of s. For this impulse response, the x of s is always equal to 1. So we can say h of s is equal to y of s directly. So from this we can obtain the inverse Laplace transform of h of s is nothing but h of t, which is also equal to the output of the system y of t. Okay. So next step here x of s is equal to 1 means h of s is equal to y of s by x of s, that is equal to, we can move this expression to the right hand side in the denominator. So we can get the value as h of s is equal to 1 divided by s squared plus 3s plus 2, which is also equal to y of s. Both are same. Okay, remember this, h of s is always equal to y of s when the input signal is impulse signal. Is that okay? So now we have obtained the system response, but we want to get the output, actual output y of t, or we can say it is a h of t also. So here it is 1 by s squared plus 3s plus 2. It is in the frequency domain. We need to transform that into time domain. For that we are going to simplify this. Okay, so the first step for getting the y of t is using partial fraction method. We can find out the roots of the equation in the denominator. So h of s is equal to what now? 1 divided by s squared plus 3s plus 2, that is also equal to 1 divided by s plus 1 into s plus 2. So these all are the roots of the given equation, correct? So here s squared plus 3s plus 2 can also be written as s plus 1 into s plus 2, correct? If we are multiplying to take this, so we need to have its roots. Okay, so if we are multiplying this two value 2 into 1, that is equal to 2. If we are adding this 2, we can get 3. So these are the roots. So 1 by s plus 1 into s plus 2. So from this we can get the partial fraction method as a by s plus 1 plus b by s plus 2. Then we have to find out the value of a and b. Why do we do all these steps? Means to find out the inverse Laplace transform. For that only we have to follow these steps. Okay. Then we are going to find out the value of a. So here a is equal to, we need to write down this expression as such, 1 divided by s plus 1 into s plus 2. If you want to find out the value of a means, we have to multiply this with the denominator of a, s plus 1, with the condition s is equal to minus 1. So when this term becomes 0, s is equal to minus 1 means this term becomes 0, right? So that is the procedure over here. So then we can cancel this two term and then substitute s is equal to minus 1 in the remaining terms. Okay, so we can get a is equal to 1 divided by minus 1. Instead of this s, we can put minus 1 plus 2, that is equal to 1. Similarly, we can find out the value of b here. So here 1 divided by s plus 1 into s plus 2, that is multiplied with s plus 2 with the condition s is equal to minus 2. Then we can get the value b as minus 1. So after finding out the values of a and b, we have to substitute those values in the partial equation. Okay, so here you can get a is 1. So 1 divided by s plus 1, b is minus 1, we can write minus 1 by s plus 2. So taking inverse Laplace transform on both sides. So now we are going to take the inverse Laplace transform. So inverse Laplace transform of h of s is nothing but h of t, which is also equal to y of t. Both are same. Okay, equal to inverse Laplace transform of 1 divided by s plus 1. So what is the inverse Laplace transform of 1 divided by s plus 1? It is e power minus t. Here it is plus means minus t. Okay, so into u of t minus, here minus is there, right? So minus inverse Laplace transform of 1 divided by s plus 2. So 1 divided by s plus 2 means e power minus 2t, correct? Into u of t. We can take this u of t as a common one. So this is the final answer. The next problem is to find the impulse response of a given LTI system using Laplace transform. So the differential equation is given here, but the initial conditions are not given. If the initial conditions are not given means we can simply assume that x of 0 and y of 0 both are equal to 0. Okay. So then in the solution part we have to take the Laplace transform on both the sides. So we can obtain the values as Laplace transform of d squared y of t by dt squared is nothing but s squared y of s minus Laplace transform of dy of t by dt is nothing but minus s y of s. Here it is minus 2 and Laplace transform of y of t is y of s, that is equal to x of s. Okay. So in this left hand side y of s is common. We can take it outside. Then we can write s squared minus s minus 2 into y of s is equal to x of s. Okay. So here the system function h of s is given as y of s by x of s. So we can move this s squared minus s minus 2 to the right hand side as a denominator value. So we can get h of s is equal to 1 divided by s squared minus s minus 2. So after that we have to get the value of h of t. For that we can simplify this expression. Okay. So here in the impulse response x of s value is always 1. Okay. Then for this equation s squared minus s minus 2, the roots are s minus 2 and s plus 1. So we can take the minus 2 here. So whenever we are going to multiply minus 2 and plus 1, we can get the answer minus 2. If I am going to add this value, I can get minus 1. So here the roots of this s squared minus s minus 2 are s minus 2 and s plus 1. So using partial fraction method, we can get a divided by s minus 2 plus b by s plus 1. Okay. After that, we have to find out the values of a and b. Here a is equal to 1 by s minus 2 into s plus 1, and that is multiplied with the denominator of this a, s minus 2, with the condition s is equal to plus 2. Okay, so here s minus 2 means we can assume s is equal to plus 2. Then we can cancel this 2 and substitute that s value as 2. So 1 divided by 2 plus 1 is equal to 1 by 3. That is the value of a. Similarly, we can obtain the value of b here. So b is equal to 1 by s minus 2 into s plus 1, that is multiplied with the denominator of b, that is s plus 1, with the condition s is equal to minus 1. Okay, so then we can cancel this 2 and then substitute the value s here. So 1 divided by minus 1, this s becomes minus 1, minus 1. So here it is minus 1 by 3. Okay. So after getting the values of a and b, we have to substitute those values in the h of s and then substitute the values like this and then take the inverse Laplace transform on both the sides. So we can get inverse Laplace transform of h of s is equal to 1 by 3 is a constant. We can take it outside, and then inverse Laplace transform of 1 by s minus 2. So here s 1 by s minus 2 means its inverse Laplace transform is yes, e power plus 2. Okay. So here minus means e power plus 2 t u of t. Okay. So then in the side minus 1 by 3 is a constant. We can take it as such. And then 1 by s plus 1. Its inverse transform is e power minus t u of t. So this is the answer for this problem. So the next problem is to find the impulse response of the given transfer function. So in this problem, they have directly given as the transfer function as such. So here we know that h of s is equal to what? Y of s divided by x of s. So we have given as the transfer function as such. Okay. So we are going to obtain the inverse value of this. Okay. So here 10 divided by s squared plus 6x plus 10 is there. So we want to simplify this further, or we want to take the roots. Okay. So for taking the roots, we can use that formula like s is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Okay, we can take like this, but instead we can use another one technique. Here it is s squared plus 6s plus 10, correct? So we can simplify this by using this technique. We can add 1 and subtract 1. If it is 9, okay, instead of 10, if there is 9, we can simply take the roots. Okay, so for that, what we are going to do, we are going to add 1 and subtract 1 in the denominator. So then we have to take the subtraction of this value. So this expression can be written as 10 by s squared plus 6s. 10 minus 1 is 9. plus 1 here. So s square plus 6s plus 9. So what all are the roots here? So here if we are going to multiply two numbers, it should be 9. So there is the possibility of 3 by 3. So 3 by 3 means 3 threes are 9. If I am going to add this 2, I can get 6. So s square plus 6s plus 9 can be written as s plus 3 the whole square plus 1 is there. So we can write like this 1 squared. So 1 squared is always equal to 1 itself. So after that we have to take the inverse Laplace transform. So here taking the inverse Laplace transform on this right hand side, we can take this 10 as a constant outside. So we know the formula here. So inverse Laplace transform of 1 divided by s plus a the whole square plus, so here instead of 1 we can write omega naught. So what is the inverse Laplace transform of this? Okay, so that is nothing but sine omega naught t, that is multiplied with e power minus at. That is the formula we have already discussed, right? So we are going to use that formula here. So 10, here s plus 3 means e power minus 3t. Here it is, if we have taken this 10 outside means it becomes 1. So that is nothing but 1. Here also 1. We can write sine omega naught t. Omega naught is nothing but 1. So sine t into u of t. So this is the answer.